Hello friends, today I'll be presenting my presentation on operator overloading in C Sharp. I'm Praveen. I work as a software engineer at MVCUS, Virginia. I work as a remote software engineer. I work from my home in India. Let's start with the topic. So these are our objectives for today. We'll be learning what is operator overloading, when is it okay to overload an operator, how to overload an operator, and the rules for overloading an operator. So in C Sharp, we have operators like plus, minus, multiply, divide, exclusive or, etc. Those are defined for built-in types like integer, float, etc. But that's not all. We can use them for the user-defined types like the struct and class, much like the same way we do for the basic built-in types. So what is the need for overloading an operator? Let's take a sample of matrix mathematical operations like adding two matrices and getting the dot product of a matrix or something like that. We would be able to uh, get an array and initialize the array and do the operations with using a for loop or similar technique to get the result, but that wouldn't make our code reusable. To make the code reusable, we have to define a user defined object like a class or a struct or something like that. So let's create a new type for these matrix math calculations. So this will be a basic matrix class. I'm hiding all those details from you to keep this sample short. So a matrix adding example would be something like this: mat1.add mat2. mat1 and mat2 are two matrix objects, and we have an instance method called add inside the matrix class. Sorry. Another example would be something like this: we have a static add method inside the matrix class, and we pass both mat1 and mat2 as parameters to add method, and it returns the result to the result object, which is also a matrix object. The problems with this implementation: it's cumbersome, verbose, it's unnatural. It doesn't look like natural. If we have too many dot products, if we introduce too many dot products like matrix 1 dot matrix 2 dot matrix 3, then it's going to be difficult to understand what's happening, and it doesn't look good. The code doesn't look good. So what are the solution for these problems? Yeah, these samples looks much better in terms of readability. We have a person with basic code understanding can understand that we are adding two matrix objects and assigning the result to another matrix object called result. In the other example, the next example, we are having a dot product of mat1 and mat2 and assigning the result to the result object. Same goes for the third example. We are doing mat1.mat2.mat3.mat4 and assigning the result to the result object. This solution is more elegant and easier to work with, and it's more readable. Anyone can understand, I would say, if you ask me. So we have seen an example where we should use the operator overloading. Let's take a look at the code where this operator overloading shouldn't be used. Yeah, the previous meta examples makes sense, and we saw that it works for basic built-in types like int and float. Sorry. Yeah, we have a bad sample for operator overloading. As you can see below, I create a car object, then we have a parking garage object which is of type garage, and I want to park my car into the garage, so I put the car object plus parking garage, then assign it to the car object itself. That maybe if we put some comments along with the code line, maybe the user or the coder will be able to understand, but not after like 6 months or 1 year. Maybe somebody else will come and they won't be able to understand the code. So that was an example, a bad example of the overloading of operator. So let's take an implementation of overloaded operator. It's much similar to a static method with couple exceptions. What are those? One is the operator keyword, and the other we have to specify the operator itself. Yeah, a sample implementation would look like this. Sorry for the caps. And public static matrix operator, and we specify the operator itself. We have the two objects we are providing to the plus operator on both sides of the operator plus as a parameter to this method. So we can do the implementation inside the block below, as you might have already figured it out. This is a full-fledged implementation of the matrix adding. So I declare a new matrix inside the method, and we do all the looping and assign the result of mat1 and mat2 into the new matrix and return the result. After declaring this method, operator overloading method, the below syntax matrix 3 equals matrix 1 plus matrix 2 becomes valid. Let's take a look at the details. The operator is static, which is the only way it can and should be declared, because an operator belongs to the type and not a particular instance. There are just a few rules you have to follow when implementing operator overloads. What designates this as an operator is the use of a keyword operator followed by the plus symbol. The parameter types are both of the enclosing type matrix. The implementation of the operator overload creates a new instance of the return type and performs a matrix add. There are certain rules. Let's take a look at what are they. One rule is that you must implement the operator overload in the type that will use it. This is sensible because it makes the type self-contained. Another rule is that you must implement the matching operators. For example, if you overload double equals, you must also implement not equals. The same goes for less than equals and greater than equals. When you implement an operator, its compound operator works also. Okay, though that's a bonus. You get it for free. For example, since a plus operator for the matrix type was implemented, you can also use the plus equals operator on matrix types. So let's conclude, guys. Operator overloading allows you to implement types that behave like the built-in types when using operators. Be sure to use operators in a way that's natural and understandable for the type. Syntax for implementing operators is much like a static method, but includes the operator keyword and the operator symbol in place of an identifier. Additionally, there are rules such as maintaining symmetry for using operators, which encourage construction of robust types. Okay, that's all, folks. Let's meet at another presentation. Thank you for now. Bye.